By May, the Indian subcontinent is a furnace. Temperatures regularly exceed 40 degrees Celsius, turning the soil to stone and leaving hundreds of millions of people waiting for a break in the shimmering, empty sky. Around June 1st, that break finally arrives. Massive, water-heavy clouds roll over the Kerala coast, bringing the first downpours of the season. Looking at a map, it's easy to assume these clouds are a local phenomenon, that they simply form in the ocean just off the Indian coast and drift inland. In reality, the birthplace of this rain is thousands of kilometers away. To find the source, we have to look deep into the southern hemisphere, where a planetary-scale engine begins to turn. To understand how these rains reach the subcontinent, we have to trace the specific geographic milestones this air crosses as it moves across the Indian Ocean. The process starts near the islands of Madagascar and Mauritius, roughly 30 degrees south of the equator. While India is enduring its hottest months, this part of the Southern Ocean is going through its winter. The water and the air above it are significantly cooler than the northern Indian Ocean. This cool, dense air sinks toward the surface, creating a massive high-pressure zone known as the Mascarene High. This pressure acts like a piston, forcing air to rush north across the ocean to escape the weight. These are the southeast trade winds, and they begin a long sprint across the open water toward the equator. As they reach the center of the globe, the air encounters the Coriolis force, caused by the rotation of the Earth. As the air crosses the equator, the spin forcefully alters its path, veering the winds right and pointing them directly toward Asia. Without this right-hand turn, the winds would continue straight north and miss the subcontinent entirely. Instead, they are now southwest winds, locked onto a trajectory toward India. These winds eventually hit the eastern coast of Africa, reaching the shores of Somalia and Kenya. Here, the air is funneled into a narrow corridor between the high African mountains and the ocean. This geographic bottleneck forces the air to accelerate, creating a high-speed wind stream called the Somali jet. This jet shoots away from the African coast, crossing the warm, open waters of the Arabian Sea. Passing over the hot ocean, this high-speed air acts like a massive vacuum, lifting billions of liters of evaporated water from the surface. Within days, a simple stream of air is transformed into a massive, floating mountain range of moisture-heavy clouds. The African mountains provided the speed, and the Arabian Sea provided the moisture. Without this sequence, the monsoon would be little more than a dry, dusty breeze. After traveling over 5,000 kilometers, the waterlogged system finally hits the southwest coast of India. The landmass of the Indian peninsula acts as a wedge, physically splitting the massive cloud system into two distinct branches. The Arabian Sea branch slams into the Western Ghats, dumping heavy rain that turns the coastal mountains into a lush, green landscape. The second branch curves around the country into the Bay of Bengal, gathering more water before flooding northeast India and Bangladesh. This arrival marks the end of the summer drought, providing the critical irrigation needed to feed billions of people. The survival of the region depends on this planetary sequence: the cooling air of the southern Indian Ocean, the rotation at the equator, and the topography of Africa, all working in sync to deliver the rain.